There he goes.
As different as we humans are from one to the next, one of many things that connects us all is our breath. And while we all use our lungs to breathe every day, our lungs do a lot of the work on their own. Our lungs moisten to promote the gas exchange of oxygen to carbon dioxide. So when we exhale, our breath is saturated with water, which creates an aerosol that comes out of our mouth and nose. We can see that by breathing on a window. If you look closely at the breath on the window, you can see that it is comprised of droplets of water. Aerosol particles from our mouths travel farther the smaller they are. Normal speaking breath is generally comprised of 1 to 3 microns, which can travel several feet before evaporating, depending on air humidity. The lower the humidity, the faster they evaporate. If you have the flu or COVID, the viruses in your lungs hitch a ride on the water droplets or aerosol. As many as 30 viruses can cram into a single droplet. When two people face each other and talk, the aerosol can travel from one person's lungs to the other's. Now try wearing a mask and recreating the fog on the window. Much less, isn't it? But not zero. Most of the droplets get caught on the mask's fibers and are blocked from flying beyond it. But not all of them. Some escape the mask and continue their journey into the open. Ancient Romans kept water in copper because they knew copper kills germs. Today we use copper in our water pipes at home and in the brass of our doorknobs. And some restaurants even have copper tabletops for the same reason. Copper, silver, and gold can all be used to weaponize masks against germs. But copper is a unique element. Its outermost electron is free and creates an electric field that disrupts cell walls and breaks down the viral and bacterial outer protective layer just through contact. So adding copper to our masks can turn them into an offensive weapon against all aerosol-based pathogens, including viruses, killing them on contact. So now, wearing a mask can not only help slow the spread of pathogens, but it can kill them outright. If you have COVID and wear a mask with copper, most of your breath will get caught on the mask's fibers, and the copper particles will kill the viruses right on the surface of your mask. If someone else near you has COVID, while you wear a mask with copper, that mask can destroy the virus before it reaches your lungs. Masks are the most effective shield we have to keep COVID at bay, and the addition of copper turns that shield into a powerful weapon. More and more copper-infused masks are reaching the market all the time, allowing us to gain an upper hand against the transmission of COVID and other viruses. While these masks are wonderful tools, it does not remove the need to continue safe social practices. We are stronger together as long as we stay 6 feet apart.
Hello, my name is Eitan Ziera. I work at DEKA, and we're working on developing special copper masks, and we've studied the transmission of aerosol and the effect of masks, and I wanted to share some of that with you. So I will share my screen. Can you see the screen? Okay, I'll continue. So when we sneeze or expel any cough and sneezing, a lot of particles come out of our mouths, and it varies in sizes, as you can see in this photo here. Very different size particles, shapes, and different velocities come out of our mouth. And for a long time, we've thought that when somebody coughs on you or sneezes, that's the only way to transmit diseases, that lung-borne diseases. What we found recently that might not be the case, and we'll go over some of those details. So in the winter, you can see your breath. That is the breath that the movie talked about, the aerosol particles that come out of your mouth in normal speech or breathing. We'll see some more photographs of that. But our lungs, as the movie said, are saturated with water. And when we breathe out, that saturated air condenses into droplets. And the condensation depends on the outside temperature and humidity, on how long they would stay and how they form. If you look closely at it, this is at 200x, and this is just me taking and focusing on the glass on the microscope, and then breathing on it, and then quickly taking pictures at different magnifications. So this is at 200x, this is at 1000x, and this is at 1500x. So you see the bar on the bottom is 100 microns. And you can see that most of the particles are in the 1 to 3 microns, maybe. Some of them might be as large as 5. But our breath really has mostly around 3 micron particles on average. It's actually been measured, and you can see the distribution of size. So it's the number of particles per cubic centimeter versus the size on the x-axis. And you can see that it averages maybe 1.5, 2 microns. So normal exhaled breath has much smaller particles than a cough or a sneeze. Why is that important? Well, if you look at a simulation of just a person breathing in a closed environment, and that person happens to have a virus that are being carried by the droplets, you can see that the simulation shows around that wall on the left side, there's sort of a dead space. So the ventilation system, as it flows through the room, has various dead spaces that the air does not flow as well. And those droplets can stay there for a little longer and start permeating the room. So over time, that kind of concentration can create droplets or aerosol throughout the structure or the room where that person is. That's been found by studying right next to emergency room, where you have COVID patients in emergency rooms, and you can find the particles 2 or 3 rooms away, depending on how the ventilation system is constructed. So it is important to understand that aerosol, as opposed to droplets that come from coughing or sneezing, can travel much farther. And so there's been a study that was done 2 years ago. This is at Maryland, so University of Maryland in College Park, UMD. And they had students, some that had the flu and others that didn't have the flu. And they're measuring, and if there are further questions, we can get a lot more into the details and how they did it and what they found. But they found that really sneezing and coughing is not so important for transmission of the influenza virus. It was more just breathing. Just the fine particles that we exhale carry the influenza virus and infects other people. And that was done in 2018. The reference is below, and if there is an interest, I can certainly send you those references so you can study that further. So what we're finding is that when you're coughing or sneezing, the large droplets that might be 100 microns or 50 microns may be, 3 to 6 feet away, but aerosol droplets can travel farther, as much as 10 meters. And it's been shown PM 2.5 are particles that have a mean diameter of 2.5 microns. And they see a positive correlation between the infection rate and the particulate matter that they can measure in the air from just people breathing. Your droplet or the aerosol, the water, evaporates after a while, but the viruses will continue flying. And so as they're flying out of your mouth, the droplets may evaporate depending on humidity faster or slower. But once they evaporate, the viruses as a cluster can still stay airborne. And that's where we're finding some of the biggest challenges for containing the virus. If there's any questions, I would welcome you stopping and asking the question. So if you put a mask on, it certainly blocks significantly, and we'll see some movies about that. But there is no better way of avoiding contamination between people or getting the COVID virus than wearing a mask. So if you wear a mask, you can block, depending on the mask, up to 95%, and 95s will block the most of the particulates, but not all of them. If you put the mask on, most of it gets blocked inside the mask, the one facing your mouth. And so if both people wear masks, it significantly reduces the chance of catching the virus. So if everybody wears a mask, we should be able to eliminate or significantly reduce the cross-contamination between people and the cross-infection that is plaguing our country right now. This is a study, a visualization of the breath with and without mask that was done by NIST. Now we'll turn the movie on. And it's a high-speed camera that shows airflow. So this is a person just breathing shallow, then taking a heavy breath in a minute. You can see how the aerosol escapes your mouth. This is not coughing, this is just breathing. If you wear a bandana, that significantly reduces the aerosol coming through, but you can still see a fair amount that comes out. If you have a mask, or those face masks, you can see that there is still a little bit, but significant. You must cover mouth and nose. Don't cover your nose, defeating the purpose. So for a tight fit around your mouth and nose, you can reduce it significantly, slow the spread of the virus. We do nothing else but just put masks on. You can eliminate or significantly reduce the transmission rate. There's another level of protection that one can do, and this is the study and the development that we've been doing here at DEKA and Army. Army is the Advanced Regenerative Manufacturing Institute, which is across the street from DEKA. We work hand in hand to develop technologies. And copper particles on contact will kill most cells. And the reason for that is because they attack the bilipid layer that is the outer membrane of all cells, whether it's a virus or bacteria or even our cells. So as a first step, just by contact with copper, you break open the bag, kind of spill the contents. Copper, as you saw, has an outer electron that creates an electric field that can interfere with large macromolecules that have electric fields around them, something like proteins, DNA, and RNA. So copper ions in the mask damage the cell wall, key proteins, and then the genes or the DNA and RNA. The way it does that is copper can go between two ionic states, cuprous and cupric copper, and those states are actually being used by biological systems for some mechanisms. And so we require some copper in our body, about 1 milligram a day of copper for our nutrition. in order to be able to sustain life. However, because of that activity, copper at high amounts our bodies are not protected against it. It can disrupt many things. Copper is unique. Other elements can do it, as you saw from the movie. Gold and silver, zinc, cadmium. Cadmium is toxic, but cadmium will do that as well. On the right side, you can see in terms of the activity, the level of activity for each element. Copper is relatively benign for us. As I said, it's a nutritional supplement that we take, and it's added into our foods. And so it is safe for people. And adding copper particles, not necessarily copper metal. So if you have copper metal as a mesh, you might turn your face green. It's not hurting, but it's going to look, if anybody has had a copper bracelet on, you can see how it turns color. And that is basically from the copper oxidizing over time. So copper creates free radicals, which disrupt cell functions and destroy. We have worked with companies to develop two technologies. We call it MedQ and Copper Shield. MedQ takes copper oxide particles, a powder, and mixes it with the plastic that the face masks are made of. The material is called spun bond, which is polypropylene fibers that the mask is comprised of. And the copper powder is mixed with that plastic. And then when you make the mask, the copper particles are infused into the fibers. Copper Shield takes copper iodide particles and makes paint out of it. So you take copper iodide powder and you mix it up with some binders, some polymers, much like paint in the house, where the paint in the house has titanium dioxide as an example, particles to make white paint, and then a binder that holds it together. And that gets coated on the surface of the mask. It gets coated in wide webs, very large rolls that might be 60 inches wide and travel at maybe a couple of 100 feet a minute to get coated. And then it gets slit down to the size into the mask making machines and then converted into masks the standard way. Copper iodide is a very safe material. It's actually added into foods. It's registered for use in table salt. And so the material is very safe for our use. It's been tested as the formulation itself and found to be non-toxic on the skin, under the skin, in the eyes of poor bunnies. Those are kind of the tests that are being done. But anyway, for our safety, it shows that the material is safe for contact with our eyes, with our mouth, and certainly very toxic to bacteria and viruses, any germs. Actually, if you think about the copper roofs on churches, the green roofs, that's copper oxide. And if you notice, there's no moss that grows on copper roofs from churches. But if you have your asphalt roof, the northern side may have some moss on it. So it shows that the copper is working on most biological entities. So the two masks, the final masks forms, the MedQ, the ones with the copper oxide particles in the fiber, are on the left, and Copper Shield with the copper iodide particles in the paint are on the right. And microscopically, the MedQ, you can see on the left side, the copper particles embedded into the fiber of the masks. These masks, if you look under the microscope, are non-woven web that is comprised of these polypropylene fibers. A scanning electron microscope, which is a surface technique, shows that the copper, some of it is sticking out of the surface, much like icebergs out of the ocean. These copper particles, some of them are sticking above the surface, and that's the ones that are active to kill the virus or bacteria on contact. The Copper Shield are much smaller particles. You can see that on the left side with what's called backscatter images. And that is if you shoot electrons from the scanning electron microscope, some of them bounce right back, just like what do you call it, billiard balls, when one ball hits another and it bounces back. Backscatter images are electrons bouncing back when they hit the nucleus or the protons in the atoms. So the bigger the atoms, the wider they appear in backscatter images. So those white dots are the copper iodide particles. And you can see some of them are in clusters, and some of them, if you can see my arrow, are widely dispersed. But the way the formula works is that the copper, some of it dissolves a little bit into the binder. And so the binder that holds it together actually has copper ions swimming in it. So wherever the virus hits, it will be exposed to a copper ion and it will kill it instantly or on contact. So these have gone through a number of tests, and we've kind of did a comparison of the two technologies. And if you think about MedQ, it's a very nice, the copper particles are embedded in the fibers. They don't go anywhere. Copper shield is paint. And if you know, the paint in your house chips after a while, so the copper shield will come off. The nice thing about the copper shield, though, you can paint anything with it. You can paint your jacket, you can paint a mask, you can paint whatever it is that you want to be antiviral, whereas the MedQ, the fibers are specifically for these masks. And so there's benefits and drawbacks for each technology. They're both available, and we're now going through the commercialization. We've gone through various tests for mask performance. These are the type of standard tests for FDA approval. And we're obviously testing the irritation, sensitization, and all these for the masks, and they all passed. They look okay. The last in progress, that's a little late. I should have changed it. It all passed all these tests. There are tests ongoing using the actual SARS-CoV-2. There's a couple of universities that have worked on concentrating them. And we're looking at what's called a 4-log, which is a 10 times 4, right? 10 to the 4th reduction in viral. And that is what we would call complete kill. So 99.99% of the viruses are killed on contact. So that's it. That's my presentation. If there are questions, I would love to either repeat some of this, or if there's questions, I would love to entertain those. I could put the movie on a loop if or wait for questions.
A couple of the questions that came in on the Whova chat. One was, do you have any solutions for those of us who wear glasses?
Yes. So the elastic, or that metal piece that goes around the nose, we found a stronger metal that when if you take the mask and try to wrap it very closely around your nose, you'll see that you do not get the fog. However, the standard facial mask over a bit of a time will loosen, and then the fog will come back. And so yes, a little stiffer metal or a little stiffer material that forms very nicely around your nose would avoid the steam or the aerosol that we talked about getting to your glasses. Was there another question you said, or? I could also loop the movie if there was a time remaining, or answer other questions, whichever is preferred.
Sorry, I have both audios going, so I had to wait till the one finished. Another question we have is, what is the impact of people continuously touching and adjusting their masks?
Oh, very good question. So, is this for the antiviral masks or for the regular mask? I'll answer both. So, when you adjust your mask with an antiviral mask, the sweat and the organic material from your hands will cover them. And so you would want to clean them. The MedQ ones are machine washable, but those should be cleaned. You could spray them and wash them or scrub them to remove the organic matter. After a while, you will kill a lot of bacteria and viruses, and the surface will get covered. And so you do want to wash them or just use them once, meaning by the end of the day, throw them away. And very important, you want to throw those in the trash, not in the street, not near surface water. Copper is used in aquariums to make sure that the walls don't turn green. But if you use too much, you will kill the fish because the fish will breathe it through their lungs. And so you certainly don't want to take these masks and deposit them in surface water. They need to go in solid waste, and that's the best way to properly dispose of them. And again, they're not toxic to people or animal, but if you put them in water and it dissolves, it will affect the aquatic life. And the answer for if it's not antiviral, adjusting the masks are fine. It's a filter without antiviral active particles on it. It's just a filter. So your hands touching it would not do anything. So keep adjusting it. Is a good idea to make sure it's tight around the ridge of your nose and under your chin. You want to make sure that both nose and mouth are fully covered.
Those were the only two questions we had in the Whova chat.
I can loop the movie for the rest of the time if we wanted to, or stick around for more questions. I'm open.
I think there was one more question. How does a face shield improve the path of the aerosol?
Can you repeat the question?
How does a face shield improve the situation?
Yes. So if you noticed from the movie, there is still a bit of aerosol that goes through. And if that aerosol travels and the reason it went through is basically because it proceeded unimpeded. There were enough holes where it kind of luckily snuck through without hitting any of the fibers. Because typically if it hits one of the fibers, it will just land on it and stay there. So those are aerosols, and think about projectiles going through, are going straight through the mask, not touching any of the fibers. And then if you have a face shield on the front, that will stop them and they will basically coalesce or get stuck on the shield. Same thing from the other's side. If somebody is talking to you, even with a mask, that would get caught on the outside surface of the face shield. Now, when there's airflow around, obviously air traveling from bottom to top could get some aerosol particles going from the room underneath the face shield, but then you'll have a mask. So the face shield is extra protection. A mask is much better protection than a face shield, but a face shield and a face mask are better than no face shield and face mask. So extra protection.
There were no more questions, so playing the video would be good.
As different as we humans are from one to the next, one of many things that connects us all is our breath. And while we all use our lungs to breathe every day, our lungs do a lot of the work on their own. Our lungs moisten to promote the gas exchange of oxygen to carbon dioxide. So when we exhale, our breath is saturated with water, which creates an aerosol that comes out of our mouth and nose. We can see that by breathing on a window. If you look closely at the breath on the window, you can see that it is comprised of droplets of water. Aerosol particles from our mouths travel farther the smaller they are. Normal speaking breath is generally comprised of 1 to 3 microns, which can travel several feet before evaporating, depending on air humidity. The lower the humidity, the faster they evaporate. If you have the flu or COVID, the viruses in your lungs hitch a ride on the water droplets or aerosol. As many as 30 viruses can cram into a single droplet. When two people face each other and talk, the aerosol can travel from one person's lungs to the others. Now try wearing a mask and recreating the fog on the window. Much less, isn't it? But not zero. Most of the droplets get caught on the mask's fibers and are blocked from flying beyond it. But not all of them. Some escape the mask and continue their journey into the open. Ancient Romans kept water in copper because they knew copper kills germs. Today we use copper in our water pipes at home and in the brass of our doorknobs. And some restaurants even have copper tabletops for the same reason. Copper, silver, and gold can all be used to weaponize masks against germs. But copper is a unique element. Its outermost electron is free and creates an electric field that disrupts cell walls and breaks down the viral and bacterial outer protective layer just through contact. So adding copper to our masks can turn them into an offensive weapon against all aerosol-based pathogens, including viruses, killing them on contact. So now, wearing a mask can not only help slow the spread of pathogens, but it can kill them outright. If you have COVID and wear a mask with copper, most of your breath will get caught on the mask's fibers, and the copper particles will kill the viruses right on the surface of your mask. If someone else near you has COVID while you wear a mask with copper, that mask can destroy the virus before it reaches your lungs. Masks are the most effective shield we have to keep COVID at bay, and the addition of copper turns that shield into a powerful weapon. More and more copper-infused masks are reaching the market all the time, allowing us to gain an upper hand against the transmission of COVID and other viruses. While these masks are wonderful tools, it does not remove the need to continue safe social practices. We are stronger together as long as we stay 6 feet apart.
Some of my favorite things about Manchester Community College, the affordability and the flexibility and the fact that it's closer to home. Ultimately, MCC is helping me get my associate degree at an affordable price, and then I can continue to any 4-year college where I can get my bachelor's degree in a year or 2.
The transfer process from MCC to a 4-year degree was very smooth for me. Pretty much all of my credits transferred over, and not even just on the general education side, but also some of my upper level classes. From getting my associate's degree and transferring into a four-year college, I came in as a junior, and now I'm a senior and plan to graduate in the spring.
I do well in smaller classes. That is one of the reasons why I want to do my nursing program in MCC. My teachers here are very patient. My statistics teacher is extremely patient. Like, he's there to help you, so you get the whole thing.
Getting involved in campus was quick and easy in my experience. I quickly became the president of the Manchester Community College Veterans Club. I participated in the Student Veterans of America Conference. I was on the CAB, which is the Campus Activities Board. If you want to be involved at Manchester Community College, it is very easy to get involved. And people are very inviting. Community really is a huge part of Manchester Community College.